Hello guys, welcome to another video. In this video, we'll be talking about how to solve linear equations which have special cases. So like special cases where when we solve linear equations. So as I said in the last video, this is a continuation of lesson 1 in unit 2. So let's get started. So in special cases, there are two types of questions that you'll be coming across. One is when the answer yields a no solution, and the second is when an answer yields in all real numbers, or basically when one side of the equation is equal to this other side of the equation. So we'll look through a few examples. First, we have 3x minus 8 equals 16x minus 13x minus 8. So let's see. So as always, I'm going to rewrite the question. So we have 3x minus 8 equals 16x minus 13x minus 8. So as I've always said, all we have to do first is basically move the variables to one side of the equation and move the constants to the other side of the equation. So let's do that. So we have 3x minus 8, and then we see that 16x minus 13x, so we have two variables on one side, so let's combine them into 3x minus 8. So you can already probably tell that 3x minus 8 is equal to 3x minus 8. Yeah, we know that. So that's basically when both sides of the equation are equal to each other. So that must be in all real numbers, right? So yes, you are right, but let's go through it all the way to see what I'm really talking about. So then we have, so let's subtract 3x. So we have 3x minus 3x, 3x minus 8 equals negative 8. And so this yields 0 minus 8, which is the same thing as negative 8. So negative 8 equals negative 8. And now we know, like we know for sure that negative 8 is equal to negative 8. So back before when you had 3x minus 8 equals 3x minus 8, yeah, it was pretty evident, but we couldn't really tell. So now we have a negative 8 equals negative 8, and we definitely know this is true. So that way we know that this is a special case that results in all real numbers. And so there are several ways you can write it. You can leave it like this, like how I wrote it. You can write it as ARL. This means all real numbers. You can write it. Let me keep that up there. You can write it as ARL, or you can even write it as negative infinity, comma infinity, because it's all real numbers. It's the same thing, right? So like there's it's like basically a sideways 8, but yeah, this is the same thing. Alright, so this is an all real numbers example. Now let's look into the next example. Alright, so we have 9x minus 8x plus 14 equals negative 11x plus 12x plus 14. So right away, it seems like a lot to do, but if you really look at it, you have a lot of really similar things from the last question. So let's try to break it down and simplify it. So 9. So we have 9x minus 8x plus 14 equals negative 11x plus 12x plus 14. So immediately, as I've said countless amount of times, let's bring the variables to one side and the constants to the other. But first, let's simplify. So we have 9x minus 8x, which is the same thing as 1x. Let's do the same thing as x. So x plus 14 equals negative 11x plus 12x. That's, again, x plus 14. So you can already see this is another example of all real numbers. But I want to do something different in this one. Instead of, let's see if there's a difference if we subtract the constants and keep the variables. Let's see if that makes a difference. So instead of subtracting x on both sides, let's subtract 14. So we have x plus 14 minus 14 equals x. And then we have x equals x. So you can see here, this is the same thing, right? Well, you'd be wondering, is this really all real numbers? Well, yes, it is. This is because x is any variable. X is a variable that has any, basically any substitute to any constant or number. So you can put like any number in there. Say x is 8, then that means 8 is 8. X is 1000. 1000 equals 1000. So there is no difference, right? So for any number, this is always be true. So for that reason, it'll be all real numbers. Like even if we had 3x equals 3x, right? That will still be the same because you're basically the only difference is you're multiplying 3 to both sides, right? So like here, let me show you what I'm talking about. Oops. So say we had 3x equals 3x, right? This is the same thing as what we did is x equals x, because all we did was multiply by 3 on both sides. In order to get from 3x equals 3x to x equals x, just divide by 3 on both sides, right? So basically, what I'm trying to say is this is all real numbers as well. And you can also put in the negative infinity format like I did in the first question. So now let's look at the last type of special case. Well, the second question was basically a continuation of the first one. So there's basically two special cases. Alright, so for the next question we have 22x plus 6 equals 22x minus 18. Alright, so let's take a look. So as always, 22x plus 6 equals 22x minus 18, right? So let's put that in here. So we have 22x plus 6 equals 22x minus, oops, about that. Alright, so now all we have to do is do the same thing as we've done several times, is move the variables to one side and constants to the other. So we would have 22x minus 22x plus 6 equals negative 18. And now we have this, right? So let's simplify. So 22x minus 22x equals 0. 0 plus 6 equals negative 18. The same thing as 6 is equal to negative 18. Now, is 6 really equal to negative 18? I don't think so. So therefore, this is not true, right? So that would mean that this is a no solution. This is not a solution. So you can write this several ways, but I'm just going to write it as no solution. And so yeah, guys, that basically sums it up for lesson 1. And so we have one more lesson in this unit. It's a fairly short unit. And so lesson 2 will basically explore another type of equation. Not a linear equation though. We'll be solving another type of equation. And so stay tuned to the next lesson and see you guys then. Thank you for watching.